What's going on, guys? Let's look at this problem right here. Here this question is asking us to find out the general solution of this differential equation. Here you can see this is the first order linear differential equation. We know this is a first order linear differential equation by looking at the power. Here the power of y is 1. If it's greater than 1, this is not a linear. And also this is a first derivative. That's why we know this is a first order. Okay. But this is not in standard form. The standard form of the first order differential equation should look like this. We have to have dy by dx plus p of x, a function of x, multiplied by y is equal to another function of x. But if you look at this one, here we have x in front of this y prime. Y prime and this dy by dx, same thing, right? But we shouldn't have anything in front of this in order to be in standard form. But here we have x in front of it. So in order to get rid of this x, we have to divide everything by x. Now let's go ahead and do that first. X, x, x. If I divide this one by x, this is going to be just y prime. And here we will have 2 over x, y. And here we will have just 1 over, this is x square. This is going to turn into just x. Okay. Now the next thing is we have to pick up, we have to find out the integrating factor. Integrating factor is called by mu. Mu is equal to e power integral of p of x dx. Now p of x is the value that's multiplying y. Okay. But if it's negative, we have to include that one too. Here you can see the value that multiplying y is this one. But here we have negative. The standard form should be positive. Therefore, the p of x is negative 2 over x. If it's negative, we have to pick up the negative value too. So p of x is equal to negative 2 over x. Now we have to bring this one into this equation to find out the integrating factor. Now here to find out the integrating factor, e power integral p of x, we found out there's negative 2 over x. So we just put negative 2 over x dx. Now negative 2 is a constant, so we can move that one to the front. E power negative 2 integral 1 over x dx, and we know that integral of 1 over x, that's ln of x. E power negative 2 ln of x, absolute value x, and we don't have to worry about the constant, because after we find out the integrating factor, we have to multiply that one by both sides. We have to multiply the integrating factor both sides of this equation. When we multiply, this constant cancel each side. So we don't need to worry about the constant for now, because at the end also we are going to add the constant together, right? So we don't have to worry about this constant for now. Now we have e power minus 2 ln of x, but we cannot just cancel e and ln like in this form. We have to move this negative 2 to this side. Now if I move this negative 2 to this side, this is going to become power of this one. So we will have e power ln power x power negative 2. Okay, and now we can go ahead and cancel this e and ln. If I cancel this one, this is going to be x power negative 2, or we can say 1 over x square. This is our integrating factor. Now we have to multiply both sides of this equation by integrating factor, that is 1 over x square. If I multiply this one by integrating factor, that's going to be y prime times 1 over x square minus 2 over x, that's going to become x 2 over x cube times y, and in the other side we will have 1 over x, because one of the x cancels, we will get 1 over x. But the reason we multiply this one by integrating factor is we can simply write this one in terms of the first term. If you bring this first term and write this one here, that's going to be same as the whole thing. Now y prime, we can write y prime as dy by dx, d by y by dx. I move this y to the front to show you something. Y, and we have 1 over x square. And we can completely neglect this other term, because if you find the derivative of this one, you will get this one back. This is going to be chain rule, and this is equivalent to this one, right? So we don't have to worry about this one, because after we multiplying the integrating factor, the first term is always going to be this one in linear first order differential equation. That's always true. So this first term, we can just first write the first term, and that's equal to 1 over x. Okay, now after we do that, we have to integrate both sides. Now we are going to integrate both sides with respect to x, here also with respect to x. If I integrate this side with respect to x, integral and derivative cancels each other. So we will get y over x square. Now in the other side, 1 over x is ln of x, ln of absolute value x. Now we have to put a constant, okay? Now the next thing is, our general solution should be only in terms of y. We have to move this x square to the other side. So we just simply bring this x square and multiply, or we can think it as multiplying both sides by x square. In that way this x square cancels and we will have the final answer in terms of y alone. Let's go ahead and write the final answer right here. So y is going to be x square multiplied by ln of absolute value x, that's x square ln of absolute value x, and then we have a constant also multiplied by x square, so x square constant. This is going to be the general solution of this given differential equation. I hope this helps. Thanks for watching and don't forget to subscribe. See you later.